Hello, Dr. K. Today I will show you my homework 3.3 to you. It's about IoT C++ and HTML. So the title of this research is ESP32 Remote LED Control via Singer.io. Okay, the project objective is build a complete IoT remote control system. The ESP32 device side C++ code connect to the Wi-Fi network and establish connection with Singer.io IoT platform. Register the onboard LED as a actuator resources that can be remotely called and receive instruction from the platform to control LED on or off states. Implement hardware level control through GPIO pins manipulation. And the web application side, HTML, JavaScript code, send control command via Singer.io with reset API, create a user-friendly web interface with clickable buttons, and visualize the current LED state in real time, and handle API authentication and error response briefly. Okay, so the significance why this project matter. I take it into four parts. You can see IoT architecture mystery is understand the three-layer IoT architecture, device to cloud to application. The master key IoT concepts is resource registration and API remote calling, token authentication, and learn how cloud platforms act as interrelational between device and application. The network programming practice ESP32 Wi-Fi connection to and plus MQTT HTTP protocol communication. Web frontend REST API calling with Brier token authentication and cross-origin request handling and error management and scalable control template, a minimal viable template for IoT remote control, and full stack collaboration. Understand the parameter matching between device resource registration and the API calls. The hardware is very simple. You can see just a ESP32, and you can see the code. The library import and configuration, we need single ESP32.h and ESP32.h. So you can see the Wi-Fi configuration. I put my SSID and the SSID password in the code. So the ESP32 can connect to my Wi-Fi and connect to the Singer.io. So then the setup function, you can see I configured LED pins as output and connect to the Wi-Fi network. Okay, then the key of ESP32 code explanation. You can see the platform authentication about username, device ID, device password, so on. Then the web application code architecture, the platform configuration constant. You can see um, I consent the single username and single device name, single resource, and single token. Single token is on the settings. And then you can see the system execution flow, step by step breakdown. The first step one is ESP32 initialization, power on and execute setup function. Uh, Initialize serial communication and LED pin. Connect to the Wi-Fi and the single.io platform. The register LED resource and interloop. The step 2 is web application setup. Users open HTML page in browser and UI initializes with LED states as unknown. The button click events are bound. The step 3 is user initialized control. User click LED on or LED off button and call the true or false function is triggered. API request is prepared and sent. The step 4 is code platform processing. Single.io received and validates API request. And using the token I gave to the give to C++ and rotate command to connect the ESP32 device. The step 5 ESP32 execution device received command from platform and execute GPIO pins manipulation and updates LED state and logs to 0. The step 6 is web UI update. Frontend receive API success response and updates UI to show new LED states and logs success message for debugging. The last step is continue listening. ESP32 maintains platform connection, ready for the next control command, and the system remains responsive to user input. So you can see the page I made. And you can see the connection issues and functional issues. I think it's very easy. Okay, so let's see the summary and key learning. We successfully built a complete IoT remote control system and implemented seamless integration between web, cloud, and hardware, and demonstrate core IoT concepts in practice and create a user-level template for future projects. The key learning IoT architecture and communication patterns, cloud platform integration, and API usage, the hardware to software co-design principles, full stack IoT development skill. And the last one is extension opportunities. Add the temperature humidity sensors for data monitoring and implement more complex control logic. Create mobile app version and integrate with other IoT platform. Or we can just build a complete smart home system. Okay, so let's see the achievement of this examination. The code is already uploaded. So the device is connected to the single IO. You can see if I click the button, API button, will on or off. Then I use visual code to uh, write this code. You can see I just make a page. Then I click this HTML. You can see the page about ESP32 LED control. If I click LED on the button, the LED will on. So you can see it clearly. Okay, that's all about this homework. Thank you.